Okay, let's look at a few examples of piecewise functions. So in this h of x function, there are 4 separate pieces over 4 separate domains. So we're just going to take them literally piece by piece, okay? So for x is less than or equal to -2, we want to know what this function right here would equal if it were -2. So I'm going to find h of -2. All right, oops, h of -2. Okay, and h of -2 is, well, 3/2 times -2 is a -3 plus 1. So h of -2 is a -2. Okay, so now if I have -2, -2, and because it's equal there, it's a closed point. And then all the x's before this, all right, are going to follow this rule, 3/2 x plus 1, which means it's increasing with a slope of 3/2. So I'm going to do my slope backwards because I want to go to the left. I'm going to go down 3 over 2. All right, and put a point, and down 3 over 2 and put a point. So before x equals -2, this is my line, okay? Between -2 and +2, h of x is just -2. It's just this value right here. Okay, so at -2, -2, if this weren't already filled in, I would make an open point there because there's a no equal to sign right here. Okay, but because it is already filled in, then that open point is irrelevant. And then when x is +2, the function value is still -2. And then in between +2 and -2, the function value is -2 that whole time. Okay. Now in between 2 and 4, your function value is just -x. So whatever x is, you just take the opposite of that. So at +2, the function value is -2, which already exists there. So that's just that point right there. All right. At +4, your function value is -4. And since there's no equal sign there, we're going to put an open circle. And then we're going to connect these 2 points. And that is how we graph the third part of this piecewise function. The last part says anything greater than or equal to +4, I'm sorry, is -5. So when x is +4, the function value is going to be -5, and it's going to be -5 for the rest of this. Pretend this is a straight horizontal line. Okay, so there are 4 separate pieces, 1, 2, 3, 4, and they are designated by these 4 functions and these 4 domains. Okay, the range of h of x, I'm going to do it in interval notation, goes from -infinity, and it hits every y value all the way up until -2. So -infinity to -2. And because there are function values at -2, that -2 is closed. Okay. For what values of x does h of x equal -5? I'm going to change my pen color for this one. Maybe if it lets me. Go ahead, you can do it. There we go. Pen color, make it blue. All right. H of x equals -5. Well, -5 is right here. So this is actually a very interesting question. Okay, so h of x equals -5 right here, right, when x is -4. So when x equals -4, and there's a whole other section where h of x equals -5, and that's this entire section right here. And if I could draw with this stylus, I would say that these two, this red line and this blue line, are overlapping. So it is when x equals -4 and when x is between 4 and infinity, or another way of saying that is when x is greater than or equal to 4. Okay, this one point and this entire interval here from there to infinity is where h of x equals -5. As x goes off toward infinity, h of x is leveling off at -5. It's never going to get higher or lower than -5 on the right-hand side. So we're saying it's approaching -5. Does h of x have an absolute minimum? No. This arrow means it's going down, down, down forever. So this minimum answer is no. Maximum is a little bit more interesting because there is a maximum value. The maximum value is -2, and it occurs on this interval. So we would say it does have a maximum value of -2. Max value equals -2. Okay. All right, let's look at one more problem here. Okay, so this problem is talking about j of x, and j of x has, sorry, my thing's going wild here. J of x has two pieces, -3x minus 10 and 1/4 x plus 3. So we'll note right here that x is not allowed to equal -4 in this top bracket, but we're interested in what j of x would be if I did put -4 in. So if I let x be -4, I would get -3 times -4, which is 12, and 12 minus 10 is 2. So when x is less than when x is -4 in this top bucket, it wants to be 2, but it's not allowed to be. So we're going to put an open circle there. Okay. And then we note that it decreases at a rate of -3/1. So we're going to make a slope of -3/1 leading up to that open circle that we made. Okay. This is the first piece of that function. The second piece goes in between -4 and +4, and it's 1/4 x plus 3. So j of -4, now it's allowed to equal -4. -4 is in this second domain. If I put -4 in there, I get 1/4 of -4, which is -1, and -1 plus 3 is -2. I'm sorry, it's +2. So we're going to say j of -4 here is +2. So what happens is, since j of -4 in the second bucket is +2, we just let it fill this point in, because -4 equals 2 in the bottom. So now what was an open circle becomes a closed circle. And now we want this to have, there's a couple things we can do. We can move from here with the slope of 1/4, so up 1/4. We also could, we know that we know that the second equation has a y-intercept of 3. So you could just put that y-intercept of 3 there to help you create the second line. Now I'm going to go up 1/4 one more time, and that leads me here to where x is 4, but x is not allowed to equal 4. We are going to go all the way up to 4 and then stop. So pretending that this line is nice and straight with a slope of 1/4, this is how I find my second piece. Okay. The range of j of x takes into account both pieces of the function. The lowest value is 2. The highest value is infinity. J of -5, if I look at -5 here, that has a value of +5. J of 2 has a value of, it looks like 3.5, but what I can do is I can come up here and say, what bucket does 2 fall in? Is 2 less than -4? No. So 2 is not in the top domain. 2 is in the bottom domain. 2 falls between -4 and +4. So I'm going to take 1/4 of 2, which is 1/2, and then add 3, and I do get 3.5. All right. J of -4, we decided was 2. All right, it's not allowed to equal -4 up top, but it is allowed to equal -4 on the bottom, and we already did that calculation. So that's a 2. J of -15, I have to decide what domain does -15 fall in, the top domain or the bottom domain. And -15 is less than -4, so it falls in the top domain. So -3 times -15 is 45, minus 10 is 35. All right, similarly, well, not similarly actually, because 8 does not fall in the top domain. It does not fall in the bottom domain, which means that j of 8 does not exist. Oops, does not exist. There's no value in the range that corresponds to 8 in the domain because 8 is not in the domain. 8 is outside the domain. So this function stops before we get there, so there's no value for j at that point.